With problems like these, it's helpful to start with a simpler example and build from there. Let's start with m equals 4. With 4 points on the bottom and 1 on top, we have 3 regions. Adding a second point up top, let's see how many more regions we add. We'll start by adding on to the number of regions we had with just 1 point on top. Connecting B2 and A4 gives us 1 more region. Let's connect A1 and B2. Let's count these triangles on top, 1, 2, and 3, as our first 3 regions. And then this last triangle up here is our 4th region that we've added to it. Then this segment adds 4 additional regions. This corresponds to 3 intersecting points with our other 3 lines. When we connect A2 and B2, this segment intersects segments A3B1 and A4B1, giving us 2 intersecting points and adding in 3 additional regions. Connecting A3 and B2, we create 1 more intersecting point and 2 more regions. Our expression for f of 4, 2 is f of 4, 1 plus 1, 2, 3, and 4. Let's see what happens when we add a third point up top, B3. We'll start with our quantity for n equals 2. We'll add 1 additional region when we connect A4 and B3. Let's see how many intersecting points we have when we connect A1 and B3. A1, B3 is going to intersect with all the segments that we have connecting A2, A3, A4, and B1 and B2. That's 3 points down below times 2 points up above, giving us 6 intersecting points. We get 1 more additional region for each intersection point. This adds 7 regions. Similarly, when we join A2 and B3, it's going to intersect all the segments that join A3 and A4 to B1 and B2. We add 1 to this quantity to get our number of regions. When we join A3 and B3, it's going to intersect all the segments formed by A4 and B1 and B2. Add 1 to that product, and we add 3 regions. We can see the pattern. We're adding an arithmetic sum, starting with 1 and with 4 terms. Let's start this process over with m equals 7. With 7 points on the bottom and 1 on top, we connect the segments and form 6 regions. Now we'll add a second point up top. Joining B2 and A7 gives us 1 more region. And now we'll count the intersecting points between each of these points at the bottom and B2. From A1 to B2, we're going to cross segments formed by each of these 6 other points to the right and B1. And we add 1 to that product for 7 additional regions. The number of intersecting points between A2 and B2 are going to be formed between these remaining 5 points at the bottom and B1 up top. We add 1 to get 6 additional regions. This pattern continues to the segment between A6 and B2. It intersects the 1 point to its right and B1. This gives us 2 additional regions. To our 6 original regions, we add the sum of consecutive integers from 1 to 7. Let's add a third point on top, connect B3 to A7. To find f of 7, 3, we'll find f of 7, 2. We add 1 region when we join B3 and A7. And now we count all the intersecting points between A1 and A6 and B1 and B2. When we join A1 and B3, we're going to form intersecting points between these 6 to the right and these 2 to the left. This gives us 13 more regions. Between A2 and B3, we're going to intersect with these 5 points to the right and 2 to the left. This gives us 11 regions, and so on to A6, B3. It's going to intersect the segments formed by A7 and B1, B2. That's 1 times 2 plus 1, or 3 additional regions. And these additional regions form an arithmetic series from 1 to 13 with a difference of 2. We'll add our 4th point, B4. We'll calculate f of 7, 4 by taking f of 7, 3, adding 1 again when we join these 2 points. And we count the number of intersecting points between all of these A's and these remaining B's to the left. Here we have 6 on the bottom connecting to 3 on top, and we add 1 for the number of regions. So we'll add 19. Intersecting A2, B4, we have 5 on the bottom and 3 again on top. that adds in 16 regions. A6B4 is going to intersect A7 and the 3 regions on top, giving us 4 additional regions. Our pattern continues, adding 7 additional numbers, this time with a difference of 3. This is our last calculation. We'll take the previous one, add 1 to it. When we join A1 and B5, we're going to take all the 6 A's to the right, multiply them by the 4 B's to the left, and add 1 to add 25 regions. When we join A2, B5, we'll have 5 A points to the right, again joining our 4 B points to the left, and we add 1, adding 21 regions. A6 has 1 point to the right and still 4 points to the left. That's 5 regions. So this is our arithmetic series with a difference of 4. Let's find f of 7, 2. That's 6 plus the sum of consecutive integers, or 34. For f of 7, 3, we'll take 34. For the rest of these arithmetic series, I'm going to use the formula where I take the average of the first and the last terms and multiply by n. In each of these cases, n is equal to 7. So the formula is really easy. 7 halves times the first plus the last. Here it's 1 plus 13, or 14. 34 plus 49 is 83. We'll take 83 and find the sum of 1 to 19 with a difference of 3. This is 153. Finally, we'll find f of 7, 5 by starting with 153 and adding these numbers from 1 to 25. And our answer is 244. If you'd like me to solve any other AMC or AIME problems, please leave them in the comments.